Well, hello everybody. This is Mr. Waters. I'm going to give you a quick lesson on solving exponential equations using logarithms. Now, this is meant to be just sort of a short intro to what we'll be doing tomorrow and Friday in class together. But we want to get at an equation like this. Let's say we've got, here's example one. Let's say we've got 3 to the x power is equal to 27. Well, you may know that we don't really need logarithms for that because we know that 3 to the x, we know that 27 is equal to 3 to the third power, right? So we express 27 as a power as the same base as the exponent on the left, and we can see here that if the two bases are the same, the exponents have to be the same, and so we would say, oh, x is equal to 3. All right, so that's equation solved. All right. However, what if we had something like this? 3 to the x is equal to, oh, I don't know, 26. Now, 26, of course, is not an even power of 3. So what do? Well, we can try this. We're going to use the power of logarithms. I'm going to log both sides. And I'm going to use log base 10, like that, because if we need to, we can find it on our calculator. All right, and we can actually evaluate numbers. There's the log key on our calculator that we can find this. Now, you may know that commonly we'll just write that log. So if you see a log term like that without a base, we just are going to assume that that's log 10. So here's what I'm going to do. I'm going to use an algebra move. I'm just simply going to log both sides, just like we might divide by 3 on both sides, or multiply by 3 on both sides, or divide by 10, or add 10, or subtract 10. I'm going to log base 10 on both sides. Just like that. Okay? Now, what does that get us? Well, you can see that we're now going to use one of our laws of logarithms, that exponent on the inside becomes a coefficient on the outside. So, we've got log of 3 to the x is equal to log 26. This x can swing to the outside, giving us this expression here in purple, or this equation here. X times log base 3 is equal to log base 26. Now, those are numbers, right? Those are actual, they're values that we could evaluate. Our calculator knows what they are, though, so we're not going to worry about it. So since I know that log 3 is a number, I'm just going to divide both sides by whatever log 3 is, like this. And that, believe it or not, is our solution. Our answer is going to look like this. X is equal to log base 3, or log base 10 of 26, divided by log base 3. Log base 10 of 3. So you're thinking, but you're kidding me. That's not a real number. So what we do, in order to kind of prove that to you, I'm going to let our calculator do the work of evaluating a logarithm, which you may have done in Algebra 2, I hope. I'm going to put it right here. I'm going to do log, here's my log key, see it? Log, and then 26, and I close parentheses. And then I'm going to hit divided by, and then log 3, close parentheses, so it does the right order of operations. And that's equal to, oh look, we'll round it off, 2.97. Now that makes a little bit of sense, I hope. If 3 to the x equals 27 gives us 3, then 3 to the x equals to 26 should be a little bit less. In fact, it's 2.97. Okay, so that's one. And we'll do a couple more examples. So I'm trying to keep this short, this video short here. I'm going to put in a couple more examples, and I'm going to give you guys a worksheet to try these on, and we'll take it up again next time. Okay, so I'm going to expect you guys to watch this video and then do the exercises I'm going to put on Canvas. Okay. Alrighty. So this, we just had example 2. So example 3. What if we had something like 4 to the x is equal to 83? Again, 4 is not an even power of 83, so we can't just cancel out the base. So what we're going to do is we're going to log both sides, okay, like this. Log of 4 to the x is equal to log 4 to the x is equal to 83. Now, strictly speaking, we can use any log base we want, but log 10 is convenient because it's on our calculators. So that just means, oh, look. So now that's going to give us, I'll write it out again so we show every step clearly. Right? We're just going to swing that x out to the front. And that's going to give us x times log 4 is equal to log 83. And now, remember, log 83 and log 4 are numbers, right? They're just irrational numbers. So I'm going to divide both sides by log 4 to isolate the x. Right? And so that's x is equal to log 83, whatever that is, divided by log 4. And that's actually a perfectly acceptable way to write the answer. Or if you're curious, you can go to your calculator and find the log key again. Log 83, close parentheses, divided by log 4, close parentheses, equals to that. And again, not an even number because these are irrational. I'm going to round that off to 3.19, 2 decimal places. Okay? Okay? And so, if we actually work backwards, we check our answer on that, and this should be true. 4 to the 3.19 should be something around 83. Not exactly because we rounded off, remember. So let's try that out on Mr. Calculator here. 4 exponent key 3.19. Yeah, just about 83. A little bit more because we rounded up. Okay? All right. So that's how that works. So that's kind of one example there. Okay. Here's another one. All right. And it's just slightly more complicated. So this will be example 4. 6 to the x plus 3 is equal to 17. Let's try that one. Going to log both sides. Log 6 to the x plus 3 is equal to log 17. Okay, again, whatever the parentheses, in this case, the entire x plus 3 swings out front. So we've got x plus 3 times log 6 is equal to log 17, right? Divide both sides by log 6, like we were doing before. Where'd you go, purple? I was using purple. Oh, there it is. Divide by log 6. Divide by log 6. And that's going to cancel, obviously. And we get x plus 3 is equal to whatever log 17 divided by log 6s. And then last step, we're going to subtract 3 from both sides. And I won't bother to evaluate on the calculator. We'll just leave the final answer like this. Whatever log 17 divided by log 6 is, minus 3. And then again, if you're curious, you can run through that on the calculator. Okay? All right, so that's kind of how that goes. All right. Let's try another one. So we'll stop right there for today, right? And that's good enough. That's about 10 minutes long. So I'm going to go ahead and wrap this video up, and I'm going to put some problems online on Canvas along with this video for you to work on. Okay? Bye.